Given a letter, create a function that returns the nearest vowel to the letter. If two vowels are equidistant to the given letter, return the earlier vowel. All letters will be given in lowercase. There will be no alphabet wrapping involved, meaning that the closest vowel to Z should return U and not A. Okay. This is an alphabet challenge, kind of. So A, B, C, D, E, F, G, I, J, K, L, M, N, O, P, Q, R, S, T, U, V. Okay. W, X, Y, Z. Okay, so this is just a generic alphabet. I guess like an initial question I would have would be, like what if, like does case matter? I guess, yeah. Does case matter? Oh, and I forgot to start my timer. Start one up here. Give myself 35 minutes. Great. Okay. So starting this problem, does case matter? It seems like that wouldn't really influence the problem too much. So we're given it a letter. So I guess that's sort of our input right here is a letter. I guess some questions I would have would be, I guess like for the input, right? Will letter always be a single character? Or can it have multiple characters? And then if so, how would we handle multi-character input string? Okay. So that's like just one sort of question I would have to pose about this question. I'm going to read the question again. So given a letter, create a function that returns the nearest vowel to the letter. Two vowels are equidistant to the given letter. Return the earliest vowel. Okay. Okay. All letters will be given in lowercase. Oh, so that answers this question. And there'll be no alphabet wrapping. Okay, so that's kind of a requirement, I guess. Letters are no alphabet wrapping. Okay. So the alphabet can be thought of as a one-directional entity. So essentially, like as they describe with this test case or with this piece of information, Z, if the input letter is Z, the closest vowel is U, as opposed to wrapping. So essentially, like thinking about Z as being next to A. So that makes it a little bit easier to think about. And they say all lowercase. So that's kind of just a general statement. Then this, so then we're going to add another requirement here. So if two vowels are equidistant, distant to input letter, return the earlier vowel. And I think when we see this word, I mean, I think it's fairly intuitive here. Like if we're thinking early in the sense of, like moving in a linear progression across this alphabet, A would occur earlier than E. So if our given letter was C, so actually let's write that test case. So what do we want to call this function? Closest vowel. Closest vowel, okay. And let's just say it's C. So the output for this function should be A, because So I guess the pair of A and E are both equally close to our given input. Okay. What about, let's just write another test case here too. Get a couple out of the way. B would just be A, pretty self-explanatory. I guess depending on, like, if we were to ask like a question about like, will the input always be guaranteed to be a single string character? And then I guess another like sort of follow-up or more generic question is, can the input ever be the wrong type? And then how would we handle that situation? Okay. I think it's fair to assume that the input's going to be guaranteed. So I'm just going to answer my own question here with yes, input type, and appropriate length are guaranteed. I hope I'm spelling that word right, guaranteed. Okay. And then for this one, we just answered that question. So sounds good. Okay, so I'm kind of struggling to recognize any other like sort of weird implicit requirements here. As far as like edge cases, I guess the edges would be like really just the end of the alphabet, because I'm thinking like say our given letter is, oh okay, so what if I just thought of one. So how would we handle like if the input letter is itself a vowel? So how what if input letter is a vowel itself? Should we return the input letter since it's technically like the closest, or should we return the or return the closest other vowel? Okay, so let's think about this. Like for let's say it's like it's O or something. So then that's 1, 2, 3, 4, 5, 6 to the left, and then 1, 2, 3, 4, 5, 6 to the right. Is that actually right? That looks like 1, 2, 3, 4, 5, 6. Okay, and then 1, 2, 3, 4, 5, 6. Okay, yeah. So this is a great test case here. Let's grab this and let's just give in O. So does it make more sense for it to be the input letter or the closest other vowel? Nearest vowel to the letter. Okay, so yeah, this is definitely like an implicit requirement here, or I guess just like this is kind of like an edge case, right? So given letter is itself a vowel, and I think it makes sense to return the nearest other vowel. So that's what we're going to do. So if input is vowel, return nearest vowel, which is not the input letter. Okay, I think that makes sense. It's a fair assumption to make. Let's make this a little bigger. So, okay, and then the edge case of like when we're at the end of the alphabet, right? So say our input is, and this shouldn't be A, this should actually be, what's the next one? I. Okay, so this should be returning the letter I. So this is like the input is vowel, and it's kind of a double. This is a test case that has double, I guess, purpose, and closest vowel is equidistant. Closest vowels, okay, are equidistant. Okay, so in that case, we want to return the one that occurs earlier, right? The earlier vowel. Okay. So essentially the one to the left, if we're thinking about this in like a one directional sense of moving from left to right. Okay. Will the input always be guaranteed to be a single string character? Okay. Yes, all right, so that's good. I'm just trying to think about any other weird test cases. Letter is itself a vowel. The other sort of challenge is, and I'm not sure if it's a challenge so much as just, an edge case. What if the given letter is a Z, right? There's nothing to the right of it, as they talk about up here. So this should just return U. Yeah, so this is, I guess, like the example of no wrapping. Okay, cool. So we've got a couple test cases. Suss out some of the details, and we're about 10 minutes in. So yeah, I want more test cases, but there isn't too much to this problem, I think. And then given Z, only look left. Only can look left. Can only look left. Okay. So, and then as far as our like data flow is concerned, we're going from like string to string, and it seems like we might want to. I'm just like I want to test something out in a REPL. Let me actually get to the right folder first, though. I think I'm in live coding. Okay, so change directory, live coding, YouTube. Okay, so node. So if we're like thinking about, we're just gonna have this alphabet, right? And I think we can just use like a string. So let's grab our alphabet. Okay, and we'll just do like that. Alphabet is this. Okay. And alphabet, let's just take a look at that. Make sure it's the right length. It is. Okay, so alphabet. Let's say we want to like match something, right? Like match A-E-I-O-U maybe. So, and that, okay, so if we're thinking about, maybe we want to find like, what if, okay, so I'm just trying to think about like sort of like approaches. I think this is a valid approach to be using a regular expression here. So I think like, for like thinking like, what if our input was B, right? If we're looking at our alphabet here, we really want to look to the left and then to the right. So can I get the, I guess, is it, I do like alphabet index of, then our input letter B, it's going to be 1. So I think I can use that method to get the left and right sides. And I'm wondering if, like, say that it's the case of Z. So we have like alphabet, or yeah, I think I'm gonna suss out some of the implementation details later on. But this is just going to be a the closest vowel, so a string closest vowel. Okay. I feel pretty good about this so far. Just gonna grab this one and okay, cool. So as far as like our summary goes, we're given a string, right? And we essentially want to so find the closest vowel given so closest vowel to a given input character, and this character can be vowel or consonant. Consonant. I actually don't know how to spell that word, I guess. Consonant. I think that might be right. Okay. It doesn't matter too much. So find the closest vowel to a given input character, vowel or consonant. Itself a vowel or a consonant. Okay. And return that closest vowel. Okay. Pretty straightforward. So first things first is maybe just have like a generic guard clause for invalid input data type, invalid input length, and yeah, I mean that's like covers the majority of weird test cases they could throw at me. So yeah, that's like the first little like step here. So then the next thing we want to do is I'm going to declare an alphabet string. Okay, so that's just like this. And given the input string, so given input string, given a valid input string, we want to do the following. And so we want to get like the left and right. So get left and right groups from alphabet based on the index of the input string character within alphabet string. Okay, so that's going to look something like we have our alphabet or something. It's going to be like just do this. So like let's say our letter is like L or something. Left would look like this. Just need to grab that. Left would look like that, including the A, obviously. And then right would look like everything to the right of the input letter in alphabet. And so then maybe just we can write like input is L, just to be clear here. Okay, and then we essentially just want to like check, like maybe we want to get like a closest left value, right? So if we have that string, be like console log, we do like left index of, and then we could do something like this would be last index of. I'm not sure if I can use a regular expression here. I mean, we could technically just loop over that given like segment left and then loop over the segment right. I feel like there's a better way to do it. I think, okay, so I think maybe we can get, how do I get the distance? Just gonna think about that for a second. So we're up to here. It's kind of unnecessary. So got the left and right groups, and for the left side, we want to find the first one moving from right to left. The first match. Okay. So it seems like we'd want to maybe just like find the vowels. That seems a little seems like a little overkill, but we could I mean I guess theoretically we could just like we do like left match and then just like AEIOU global, and then get like the last character. So like left length -1. Well, actually, it's just we can let's just see what we have here. So it should be like A, E, and I. So we do like node nearest vowel, and I'm wondering for my test case, yeah, they're gonna break it up here. We'll just comment that stuff out for now. Okay, so if I run our code, we're seeing that, right? And so maybe we can grab this. So we'll just call this vowels left. And maybe we just let's log out the last element, and that would be the one that is closest to our given input string. So, okay. Sounds good. So, if there aren't any vowels to the left, so I guess that's, yeah, that's another edge case I should consider. So given A can only look left, given A can only look right. Okay. I should write that test case. Do closest vowel A. All right, and then this should be E. Okay. So, all right. Yeah, okay, that should work. So if we have that, and then maybe just get like closest, or if we get the, we do like vowels left dot, or vowels left length -1. Okay, and then we can just maybe do like closest vowel this. Okay, and then if we log out closest vowel, we should see that we should see I being logged to the console, and we do. So that kind of works, but we still don't actually have the distance, right? So I think we can just take the character code, yeah. So that would be, let's do character code at, and we could just do at index 0, right? So that would be 105, and then we could just subtract, we get the absolute value, or I guess the absolute difference between left and right. Okay. Okay. So if we had like that, and then maybe we take input, input dot character code at 0. All right, so if we just log out those two values, I think we just take the absolute value, the absolute difference. So I think that's a valid approach. I'm just gonna comment this stuff out and get back to the algorithm here. So I want to get the left and right groups, and if left or right is empty string, so I guess we can just do if left is empty string, then we want to just ignore left side. If right is empty string, ignore right side. Okay, so that's the situation where it's Z or A. And now we need to, so we've got the groups, right? So we have left and right groups, and basically we want to check to see if there's a vowel for vowels left. So find if there are any vowels in the left string. Okay. So search for vowels in left string and get the last element in the returned array. And in the case where it's null, how would we deal with that? So search for vowels in left string and get the last element in the returned array unless the return value is null. Okay. And so then search for vowels in right string and get first element in returned array unless the return value is null. Okay. So how are we going to deal with this situation? I guess I'll finish filling out like what I sort of found in my exploration. Basically just get absolute difference between character code for input letter and character code for vowels, for found vowel, if found, and do this for both sides and return the smaller value, or return the character with the shorter distance, or if they're equal, return the one found on the left. And I think maybe you can just use actually the character codes themselves. So return the one with the smaller character code. Okay. All right. So grab our test cases. Okay, I'll drop them down here. Okay. Oh. Oopsie. Get rid of that. Okay. So I've got that. And so we want to guard for invalid input. Closest vowel letter, or I will just call it L. Okay. And if type of L is not equal to string, I want to return invalid input. If L length is not equal to 1, then we want to return invalid input length. Okay, invalid input type, invalid input length. Okay, so we have our little guard clause out of the way. So now we want an alphabet string. So we'll just grab this and do const alphabet. Okay, and that'll just be this string. All right, and when you get the left and right groups from alphabet based on the index of the input string character within the alphabet string. Okay, so we'll just do const index, our L index. Okay. And that's just going to be, we'll do alphabet index of letter. Okay, and let's just return L index just to see where we're at. So we've got, for the test case of C, its index is 2, that makes sense. B is 1, 25 for Z, 14 for O, and 0 for A. Okay, that makes sense. so far so good. So I want to get the left and right groups. Okay, so how we're doing that is, I think, just slicing. So for the left one, const left side is alphabet dot slice from 0 up to L index, and let's check that here. So left side, let's just return that. So we're seeing A, B for this test case, which is not what we want. So let's decrement that value. Yeah. So if we run our code again, we're seeing what we want to see. A, and then element O. Okay. O, and then so L, M, N. Did I just forget N? No, it's there. That's concerning. A, B, C, D, E, F, G, H, I, J, K, L, M, N. Wait. A, B. Did I just wait? Oh, it's C. Oh, okay. I was reading this wrong. So yeah, that is correct. And we're getting it up to that length. So okay, cool. So that's looking good. So now let's get the right side. Okay, and that's gonna be alphabet slice from letter index up to just the end. So if we return right side, okay, seeing A, B, C, and so we don't want it to, so actually we want to, yeah, this is just an adjustment of 1, so D, E, F, G, okay, and it's for the third one, O, it's starting at P, element of P, yeah, okay, so cool, all right, so that looks good. For our purposes, got about 3 minutes left on our 35-minute timer. This is taking me longer than I thought it was going to take. Okay, so we have the left and right groups, and so if left, I guess it doesn't, does it even matter? Can we, I think we can, yeah. So, okay, I'm just going to write it like if neither, so if left side is not equal to that and right side is not equal to empty string, then we're going to do the following, and then else if left side is equal to that string, then do this, and then else if right side is equal to empty string, and do the following. Okay, so for when neither of these is an empty string, so for anything that's not an A or a Z as the input, so we're thinking about these two or these three, we want to search for vowels in the left string, get the last element in the returned array, unless the return value is null. Okay. I wonder if that even, if it will ever be null. I guess it could be, well, so it's not going to be null for either, for any of these, but it could be null for these. So maybe we can just handle these independently in those, these portions here. So maybe I just focus on not, I don't have to worry about null being returned, I think. So well, what we did earlier was essentially just checking the vowels in the left side, right? So let's just do that. So this is going to be What are we going to call this? Well, I guess we called it vowels left. Okay, so just const vowels left, and this is going to be equal to left or left side match, and we can just grab this regular expression, left side match, that expression. Okay, and once we have that, we can get the closest vowel. So const closest vowel is vowels left, and then vowels left length minus 1. Okay, and that's that. So then let's just log out, console log closest vowel. And let's get character code at, okay, 0. So, and we're not going to run these two test cases for now. I just want to see what the closest vowel is on the left side for each of our test cases. Okay, so it's 97, 97, then 105. So that makes sense, right? Because on the left side, it's A for both of them. And then on this side, it would be the I, correct? Where's our alphabet? Yeah, it's the I. So we're getting that side. All right, so we have that. And now let's get const vowels right. And it'll be right side. Same situation here. Okay, and then const closest left. Closest left. Okay, and then closest. And I see I ran out of time, but I've still got a couple minutes before it's hitting 40, so I'm going to keep going. Right. Okay, and then this is going to be right side. Vowels right. And length. And this is actually, we want the first element, right? Yeah. So 0. Right side 0. And let's just return, let's log. So console log. Let's get left and right. So we'll just do closest left and closest right. Okay. So we've got A and D. Wait a minute. That's strange. Why would that be closest right? Right. Oh. Vowels. Vowels right. Yeah, okay. So I was accessing the element at the 0th index, or the element at index 0 in this up here. Sorry, this up here, right side. So that was why I was getting that error. So A and E, and I and U. Great. So that is working. So now we just need to find the absolute difference for both of those, right? So let's do const left diff, and that will be the absolute value of subtracting vowels right. We want to subtract, where did we do this? So we want to subtract the character codes, right? So absolute value, and then it's going to be closest right. Okay, so our closest left character code at 0 minus closest right character code at 0. Let's just return that out at this point. Left difference. So we're seeing 4, 4, and 12. Does that make any sense? I'm not sure. It doesn't seem like it would be. Oh wait. Sorry. We're getting a little tired tonight, so that it should be L character code at 0. yeah, 2, 1, and 6. So does that check out? Yeah, so that's 2 to the left, 1 to the right for or sorry, 1 to the left for this character, and then 6 to the left to find I. Okay, so that's looking good. So now we want to get const right diff. That'll be math absolute value and just closest. Can do, yeah, closest right character code at 0, subtracting L character code at 0. If we return right difference, we're seeing undefined. Okay, now we're seeing 2, 3, and 6. So yeah, all right, so now we have those two differences, right? And what does our algorithm say we need to do next? So do this for both sides and return the smaller character with the shorter distance. Smaller character with the shorter distance. Okay, so I guess it's if left difference is equal to right difference, then we want to return the left character. So vowels or closest left. So return closest left. Else if left difference is greater than, or if it's less than right difference, then the we want to return the one on the left, right? So return closest left. Okay, and then else if left difference is greater than right difference, then we want to return closest right. Okay, so to run our code here, we're seeing A, and I, which is what we expected. Great, but we still haven't dealt with these two cases, so let's bring those back into the fold. We're at about 42 minutes, so kind of going over. And the code, the way I'm doing this is quite verbose, but we're a little tired, so that's okay. So okay, we've got that looking good. Okay, so this is left side empty. So if this is essentially like if A, and this is if Z. So I think there it might even yeah, this is I'm not sure if this is the best, most appropriate way to do this, but we essentially just need to take like one side of what we've already done here, and yeah, so like for the, can I just collapse this? No, not too well. So for the left side, so if it's A, right, that's what this means, then we only want to look to the right. So we essentially just need to get, I wonder if there's like a way to do like index of and then like a regular expression. That would be neat. I'm not sure if it's possible. I'll have to look it up after this, but so if we're thinking, okay, so closest right, we just take this, paste it down here. Okay, so that's working for that. And there's a lot of copied code, I think. Yeah, except, so this is just, we can just return closest right. And then for this one, we can just return closest left. So return closest left. All right, and let's bring the, are they already? Yeah, they're already uncommented. So run our code A-A-I-U-E, and we solved it for the test cases we've written. So that was about 44 minutes, not great time-wise, and really like kind of a sloppy solution. I usually don't like to have, 5 return statements. It's not really that great, but I'm kind of tired tonight, and yeah, I mean, I think this is understandable. It's a digestible solution, if not the most like optimal one. But yeah, made it to a solution, and I have no idea if I'm actually gonna post this video, but yeah, this was fun, if a bit frustrating. And yeah, thanks for watching if you made it this far. Peace.